Hello students. So here I have come up with my second class on operational amplifiers. So as you can see, today's our topic is block diagram representation of typical OPAMP. So I want my students to mark my words that this is one of the very important question in VTU. So all of you concentrate. Okay. So in the diagram shown on the screen, as you can see, it has four stages. Okay, four stages. That is input stage, intermediate stage, level shifting stage, and output stage. So let us see one by one in detail. Let me zoom this. Yes. So let us see the first stage, that is input stage. The input stage is provided with dual input, that is inverting and non-inverting inputs, which you can see from the diagram. These are the two inputs, hence it is called as dual input. Okay, it has a differential amplifier which takes the dual input and produces an balanced output. So now in the above point, in the yes, as you can see, it is a differential amplifier. First you should know what the differential amplifier is. The differential amplifier means it takes the difference of two inputs, that is inverting and non-inverting, then it amplifies the difference. It amplifies the difference of these two inputs and gives out the output. This is the role of differential amplifier. Okay. So the differential amplifier here, it has a high input impedance. This high input impedance is must, which is very essential here. Why, I will explain you in detail in the topic of OPAMP characteristics when it comes, probably next class. Okay, the input impedance should be very high here, and this is provided by this input stage. So this stage provides most of the voltage gain of the amplifier. Means whatever is essential, it is provided in the this stage, the voltage gain. Fine. So next stage, let us see which is the next stage. Intermediate. Intermediate stage, this is another dual input differential amplifier. What it means? It is similar to your previous stage. There also it has a differential amplifier. Here also you have a differential amplifier. There also it has dual input. Here also it is dual input. Dual input. Now the only difference in this stage is the output is single. There in the input stage, the output was balanced because it was giving out two outputs in the previous stage, whereas in intermediate stage it is giving out single output. Double is made into, two is made into one. So this makes it unbalanced. Okay, this is why it is denoted as unbalanced differential amplifier output. Well, so this stage produces unbalanced output because it takes two inputs and gives out only one output. Fine. Another important thing is that the overall gain requirement of the op-amp is very high. Now, our previous stage, that is input stage alone cannot provide such high voltage gain. Hence, an intermediate stage function is to provide an additional voltage gain which is required by the op-amp. So our previous stage, what we have seen in, that is input stage, is not capable of providing the voltage gain required by the op-amp. So to add on, to increase the voltage gain, we require this intermediate stage. So practically this intermediate stage will be of a form of like a chain of cascaded multi-stage uh, differential amplifiers. Multi-stage differential amplifiers. Cascaded means connected back to back. A chain of amplifiers connected back to back. This is to increase the gain. This is to increase the gain. Okay. Now the next stage is level shifting stage. The level shifting stage, I'll zoom it here. Yes. In level shifting stage, it brings the DC voltage level to the ground potential, to the ground potential. When no, this is when this happens only when no signal is applied at the input terminals. Then the signal is given to the last stage, which is the output stage. So for in this stage, level shifting stage, we make use of emitter follower, just a simple emitter follower, where the DC level, DC output, DC voltage level, which might have increased because of cascaded multi-stage differential amplifiers. So this this DC part, the DC voltage level will be brought to ground with respect to ground. Zero means brought to zero with respect to ground. So then the final output is given to the last stage, that is output stage. So let us see what happens in output stage. So in output stage, a push-pull complementary amplifier is used. Now the question is why this amplifier is used. The purpose of using this push-pull complementary amplifier is that this will increase the output voltage swing and it raises the current supplying capability of the op-amp, and it also provides a low output impedance at the output of op-amp. So these are important points here in the output stage, that the output of the or the output impedance of the op amp is very low. It should be very low. This is because if it is not low, then it is not capable of supplying current, or it is not capable of driving a load. So it can be made capable of driving a load only when it can supply current, and this can be made possible only when the output impedance of the op amp is less. So this should be less. Okay. So this will end your block diagram topic. So these are the four stages. This is how you have to briefly detail in your answer. So let's see further in our upcoming classes. Okay. Till then, thank you. Bye.